The process is the same. We're going to test using a t distribution instead of a z, which still is a normal curve, but remember the t had different degrees. Like you saw it like go like this, and then it came like this. It came closer and closer to a normal curve. As n approached 30, it got closer and closer to a normal curve. So the only difference between this and our z is we're going to use a different table to find your critical values, and in this case we don't know our population standard deviation. So if you remember back to your confidence intervals, the t was always slightly wider than the z one, if you remember those. So the t is going to be slightly a little bit different than your z. It's going to give you a little bit more wiggle room when we do this. We're still going to identify your level of significance. Because we use your t, we're going to identify your degrees of freedom. We're going to use your column, and we can do this on your calculator. If you remember when we did the t, it's a little bit more difficult. There's an inverse t out there, but it's a little weirder to use. This table is nice because you're already a one-tailed and two-tailed. You don't have to divide anything by 2. So I kind of like, if you like using the calculator, that's fine. I kind of do it without. I like the table for this. It's an easy table to follow. So the major difference is your critical values. So if I have a left-tail test, I'm shading in on the left-hand side. Instead of ZC, I want TC, or T sub 0. They use the 0. I usually use the C for a left-tail test. Now, normally, for your z-score, we looked up your 0.05 and your inverse norm, and we found your associated ZC. However, this time we're using table 5. So we're going to look up your degrees of freedom, and we're going to look up the column on top. But this is a one-tailed. So look how nice this is. Turn to page 818. Follow degrees of freedom 20. Follow one tail for 0.05 and tell me what that value is. 1.725. Now, because it's to the left of the 0, it has to be negative 1.725. That's how easy it is to find your critical value. This is your cutoff value in my top right drawer. File drawer. That's how easy it is to find this. This is my reject, H0. That doesn't change. This is my fail to reject, H0. This is not going to change. All that's going to change is how I look up that value. If you use your inverse t, you can find it on inverse t, but it's much easier if you do it this way. So do this one for me. We have a left tail test. See if you can find me your critical value cutoff. When your level of significance is 0.01 and your n is 14. What's my degrees of freedom here? 13. So you're looking up degrees of freedom 13. See if you can find me your value. Oh, 650. Everybody get 2.650? Did everybody look this up? And because it's on this side, negative 2.650. If it was a right-tail test, let me turn this into a right-tail test. Watch how easy this is. Right-tail test, what's your TC? 2.650. You just take the positive of it. The one tail goes for either side, left or right. Okay? One table to look up. So if you know what a right hand does, let's look up a two-tail test. I have a two-tail test. These are both my reject HL. Fail to reject HL. Watch how nice this is. Go to your table. What's my degrees of freedom here? 25. What tail test do we have?
2.
2. Come down 25 and go across the 0.10. 1.708. So this guy is negative 1.708. This guy is positive 1.708. That's the only difference here. But they give you the column, 1 tail, 2 tail. They take care of taking your 0.10, dividing it by 2, and finding it.
Can you do this in your calculator?
In your calculator, you have to go to your inverse t, and you're going to have to tell it 0.10 divided by 2. Oops. What comes next? The 0 and the 1? I don't have a... Oops, I forgot. I don't know what your statement. What is it asking me to put in?
Yeah, area and then degrees of freedom.
Oh, area and degrees of freedom. That's what it is.
Yeah.
Area and degrees of freedom. That's what's nice about having it already in your calculator. So what was the degrees of freedom? 25? Oops, still doesn't like mine. Area. Try again. Area is 0.10 divided by 2. And degrees of freedom. It doesn't like this. Maybe it just doesn't like my divide by 2. Let's try this again. Put this in as a 0.05.
Well, in the other country. Yeah, in the software is doing it.
It's working in yours?
Yeah.
Okay.
Because it has, it's like
I'm doing this drunk.
I still can't do it in mine. Can you do it in yours?
Yeah.
Oh, I want to take out the divide by 2. Hang on. There it is. I can't do a divide by 2 in mine. At all.
The calculator? No.
What?
You don't put all that in the calculator?
No, I did it wrong like 5 times.
Oh.
Your calculator has the software for it. You can divide by 2. I can't on the old software. And on the 83s, you're not going to be able to divide by 2 either. Just do the divide by 2. That's why I'm saying the table is so much easier. You look up degrees of freedom, say which tail you are. If it's on the negative side, it's a negative value. A positive side, it's a positive value.
But if it's a one-tail test, we don't have to divide it.
No, you don't have to divide it at all. Okay, so find me 2-tail test. Find me your critical values when n is 16 and your level of significance is 0.05. You all need to be able to use this table to find this value. What you get? Is that it? 2.131? No, I didn't doubt you. This side is negative. I go to my go-to girl here. She knows. I had looked it up and then I completely forgot what it was until I started talking. I didn't doubt. I just checked. Okay, so are we good with this part? Alright, so the rest of it's not going to be that different. Your test statistic looks pretty much the same, except for, instead of your population standard deviation, we have your sample standard deviation, which means that it's going to be given to you with your sample. If you're given a string of numbers that you have to put in your L1, you have to pull out your SX, your sample standard deviation. But the rest of this is pretty much going to look like the same thing. Okay? And again, the steps for finding this, we're going to verify that your population standard deviation is not known, that your sample is random, and that either the population is normally distributed or n is greater than or equal to 30. They have to tell us one of those pieces. If the sample size is less than 30, again, it has to tell us that it's normal distribution. We state your claim as we did before. We specify your level of significance. We find your degrees of freedom, we sketch, we find your critical values, we label your reject region, and we find your test statistic. And we interpret your decision. Okay, so let's try one. This is not going to be that different than what you did. So, I'm kind of hoping that if you're struggling, you're still paying attention so that you can see where you're going wrong with this, and you can get this under your belt. This is important. We follow the same steps every time. We specify your claim. You can know when it has the equal sign. The not equal sign is the HA. That's the tail. You're still going to sketch. You're still going to give me the reject HO regions. And the only thing is, with your p-val, with your p-val, do you notice on your table you can't pull off the p-val? You can only find your different than your formula sheet, different than your A. Your A gives you your standard deviations on the side and your areas in the middle. Your table 5 does not give you area. So you can't find a p-val off your table, but you can find a p-val off your calculator. So we're going to put this in, we're going to do a reject region, and then I'm going to put it in your calculator and test your p-val. You can't find the p-val from your table though. So that has to go. TJ, from now on, that is your C.
I'm being so quiet. I'm like,
Yeah, like
paying
this.
attention.
Yeah, like I can't see you. Okay, so let's take a look at this. A used car dealer says that the mean price, again the mean is your mu, of a 2-year-old sedan in good condition is at least $20,500. You suspect at this claim, that was my claim, is correct, and you find a random sample of 14 similar vehicles that has a mean price. There's your sample information. They have to tell us that the population is normally distributed because N is less than 30. But we're going to pull out your same information. So let's take a look at your claim. The dealer says this is his claim. How do I write the claim? TJ, how do I write the claim? What? How do I write the claim?
Great claim, there you go. Thingies. I know it's really supposed to pay attention, but
Oh, but you are paying attention back there, I thought.
at least, so it's
Daniel, how do I say to mean that's the claim?
At least, so it's less than 20,500.
Is at least. At least. That's the least you have.
I
Equals to 20,000.
I just said that. Did I not?
Okay. Is that the HO or the HA?
HO.
HO, because it has an equal sign. What's the HA?
Mean is less than.
Okay, what tail test do I have?
Left.
Why is it a left?
That's HA.
HA, the arrow points to the left. So I say, reject H0 here. Fail to reject H0 here. If you do not say H0, then it's wrong. Because I could be rejecting the claim. I could be rejecting the HA. Now, next step, find me a TC. My level of significance, well, let's pull out your sample information. Your sample mean is 19,850. Your sample standard deviation is 1084. Your N is 14, and your level of significance is 0.05. Find me a critical value cutoff.
Negative 1.77.
Negative 1.771.
Oh, yeah.
Okay, I need this. This is my cutoff. If I find my score, my t-score, my test statistic, and it falls to the left of this number, I'm going to reject HO. If it falls to the right of this number, I'm going to fail to reject HO. So I do my test statistic. This is the same as we did before. only we use your sample standard deviation instead of your population standard. We have no choice. They didn't give us a population, so we know it's our sample. So X bar 19,850 minus your population over your standard deviation divided by the square root of n. Now you'll find your test statistic. I'm going to show you in the calculator in a second. This is your test statistic. What do you get? 2. Thank you. Okay, now, this is a t-square formula.
Well, it's the same.
It works the same way. Now, we take this and we compare it to this guy. Is it to the left or to the right of negative 1.77? To the left. Here, and I want to see you put it here. So your decision is reject what? Reject HO. Now, I'm rejecting this. I don't like this. I'm going to have to go with this guy. But I have to follow my chart. My claim is the null statement. I'm rejecting the null statement. So there is enough evidence to reject the claim that the price of a 2-year-old car is at least $20,500 at a level of significance of 0.05. Okay. Notice we can't find a p-value for this. When you look this up in your table, there is no area. The problem with the t-curves is the area keeps changing. The area is always equal to 1, but your curves change. Your curves start off like this, and then they get a little bit lower and lower and lower. The tails keep getting lower. So the actual value of the area changes. So there's no way we can look it up on your table. However, on your calculator, go to stat, go to test. Which one do you think you use? T-test. So put your information in. There's your, you would have never thought that. There's your population mean. Here's your sample mean. Here's your sample standard deviation. Here's your N. It'll do degrees of freedom for you. Follow your tail for your HA. Your HA is less than. Calculate. There's your T that we found. Look, there's your p-value. So if you wanted to, you could test your p-value. Your p-value is 0.0215. So if we test p-value against level of significance, this is less than or equal to, my decision is still the same. Still reject H0. If you put it in your calc, you get your TC anyway. So it doesn't matter. That's the only place you're going to find your p-value is in there. Questions? So same as before. Same as before, but I think your cutoff is a little easier. Because the table is set up where you say, yeah, but the table is nice too because where some of you forget to divide by 2, you really don't have to do that. You have a 1 tail or a 2 tail. So the only thing you have to do is place the negative sign if it's to the left of the 0. It can't be positive to the left of the 0.
It's right tail. You inverse T1 minus it.
If it's right tail, no. It does. I don't think it works that way on a T.
So it's the same thing?
It might work that way in your calc. My calc doesn't work at all like that, so it might work on the new ones. I have to try it.
You need to get the 84 on there.
Yeah, I know. Well, I do. I just have to figure out how to. So my claim. Damani, what's the claim?
The claim is the HA, which is the mean is less than 1200.
Good. So the tail is a left tail test. HO has the equal sign. Okay. Pull out your information. You sampled 7, so what is your degrees of freedom? 6. Your mean is 1125. your standard deviation 55 at a level of significance of 0.10. Either do inverse t and put in 0.10 or go to your table to the 1 tail, degrees of freedom 6, and you'll find this critical value to be this. Okay, that's our cutoff. Critical value, that's why I like to use the C for cutoff. Do your test. This is your test statistic. It's the mean from the sample minus the population, because you want it to be negative anyway, so subtract the smaller minus the larger. Guys, don't pack it up. Use the n, 7. So you found your t to be negative 3.61. Take this guy and see where it falls. You should have labeled this reject H0 and failed to reject H0. It's falling right here. Show this to me. So your decision is reject H0. Your interpretation is, let me follow my chart.
Do we
My
have
claim
to?
is HA. Yes, you do.
We have to interpret it.
Yes, you do. Reject H0. There is enough evidence to support my claim that the mean cost of insuring a 2-year sedan is less than $1,200. That's what your goal is through this whole thing. Do you support this? Do you reject this? It's kind of, did you do your research and decide if you liked it, read it,